All right, here's the answer to those bell work questions. The only thing you have to make sure you keep track of is your zeros. Because obviously we don't have every element accounted for here, or every variable accounted for. So we only have 5 x's. So in the x column I put a 5. We have 0 y's, we have 0 z's, and that equals 6. Continuing on, we have negative 4 x's. We have 0 y's. We have, there's a mistake. Where's the mistake? It's on the next one, right? Yep. Then we have 4 x's, 4 y's, 0 z's, and 7 is our answer. There's definitely a mistake over here, primarily right in this region here. See if you can locate it before I get to it, even though I circled it. You just got to figure out where. So this says we have 1x, 3y, so I have 1x plus 3y equals 5. On the second row, we have 0 x's, so I don't have any x's in that one. I have 1y, so we have 1y minus 4z equals 8. On the bottom row, I have negative 2 x's. I have 0 y's. However, on my answer, it says that there are 5 y's. That should be 5z. So it should say negative 2x plus 5z equals 7. Questions, comments, concerns on those? Because if you can't do those, you can't move on. All right, questions from the homework. All right, then continuing on. This is about as big of a problem and as hard as the problem is going to get on this particular issue. We are going to use Gaussian elimination to solve this system of equations. Normally I won't give you a 3 by 3. Actually, this is going to be a 3 by 4. But normally I won't give you one this big. There's one in the homework, but normally I just use the 2 variable ones. I'll save these for mostly just calculator work. And don't forget your calculators tomorrow. Don't forget your calculators tomorrow. We will be using them. All right, so we're going to use Gaussian elimination to solve this, which means we're using matrices. So our first step is just to put that system of equations into a matrix. So in that top left one, we're going to go ahead and put 2 down because we have 2 x's, minus 1, 1, and that's going to equal 1. Second row, I have 1x, I have 1y, I have negative 2 z's, and that equals 5. And finally, our last row is going to be 3, negative 1, 8. With Gaussian elimination, our whole goal is to turn this entire row into 1s and then turn everything else into 0s. So that blue stripe should be 1s when we're done, and everything else should be 0s in there. With Gaussian elimination, we do it step by step so we don't make mistakes along the way and we don't switch up stuff we already did. Our first step is go left to right. So we go to our left column and we deal with that first. We're just looking at our left column right now. Now our next step is to locate which value needs to be 1 and turn it into a 1. So what needs to be 1 is that 2. Because like I said, for that identity matrix, maybe I'll write that down above, our end answer needs to be, that's a little small. Our identity matrix has to look like this, where we have just numbers on the other side. So that's our end game. Diagonals of 1s with 0s everywhere else. That's our end game. Currently I have a 2 occupying where I want it to be 1. There's 2 methods in this one to turn it into a 1. I don't know, like 75% of the time, maybe more, you would just multiply this entire row by 1/2. And it would work for this one. If I multiply this entire row by 1/2, we would have 1, negative 1/2, 1/2, and 1/2. That's a lot of 1/2s in there. It's fine. You can absolutely do that. A trick to a problem like this is we're allowed to switch 2 rows. So if we were to switch these 2 rows, I would have a 1 in that spot. And I wouldn't have to do any multiplication. Most of the time you have to multiply that top row by 1/2. Most of the time. But in this one case, I have a 1 right below it. So I'm just going to swap it so I don't have to do any multiplications. So I'm going to swap those two rows, but first I'm going to say what I'm going to do, and then I'm going to do it. So I'm going to say take row 1, swap it with row 2, but we need a double arrow on it because they're both taking each other's place. So row 1 is going to replace row 2, and row 2 is going to replace row 1. So now we are going to have 1, 1, negative 2, 5, 2, negative 1, 1, 1, and finally 3, negative 1, 8. My whole goal is to put a 1 up there. We have 3 ways to do it, and this is one of our ways to swap our rows. So we're good. We got a 1 there. Our next step is to make everything else in the column 0. So we're actually going to do 2 things in this one step. On Friday, we only did 1 thing on each step. On this one, we're going to do 2 separate things on the same step. We are going to turn 2 into 0, and we're also going to turn this 3 into 0. Since we can't multiply both sides of an equation by 0, we have to do something else. And that is creating 0 pairs. We're going to create 0 pairs with that 1. So think about this. We know what needs to be 0. What you're going to do in your head, let's do this. No, that's not going to work. You're kind of thinking about everything else disappears. All right, I'm going to make everything else disappear. You're just focusing on this row. That's all you're looking at right now, or this column. And you're asking yourself, what do I have to multiply 1 by? And when added to 2 becomes 0. That's all you're asking yourself. That's it. And it's not a trick question. You just have to multiply this row by negative 2. If I multiply this by negative 2 and add it to 2, it turns to 0. To get rid of this 3, I need to multiply this 1 by negative 3 to create that 0 pair. That is that entire step right there. What I just said is the entire step that we're doing. I got to bring everything back because we have to remember we're doing everything. So the first thing I'm going to do is I'm going to eliminate that 2. In order to get rid of that 2, I need to multiply that 1, which is in row 1, by negative 2. So we're going to do negative 2 times row 1, and we're adding it to row 2. So I'm just doing negative 2 times 1 plus 2 gives me 0, and I'm going to replace row 2 with that information. So let's do all that before we get to the 3. First of all, I'm not doing anything to row 1 because that is that 1 I want to hold on to, so we'll just write row 1 down as 1, 1, negative 2. 5, I'm not changing that row at all. My next step is to multiply entire row 1, add it to row 2, and replace row 2 with that information. So let's go step by step. We're going to take that negative 2. Remember, we're just kind of going row by row. So we're doing negative 2 times 1 equals negative 2 plus 2 is going to give me 0 in row 2. Then we take this negative 2 on the next column. Negative 2 times that 1 on the top. Negative 2 times 1 is negative 2. Negative 2 minus 1 is going to be negative 3. Continuing down the row, we have negative 2 times a negative 2. Gives me a positive 4. 4 plus 1 is going to give me 5. And finally in that row, I have that negative 2 times that 5, which is negative 10. Negative 10 plus that 1 from row 2 is going to be negative 9. Now I'm going to do that 3. I need to get rid of that 3. Once again, you just ask yourself, 1 times what creates a 0 pair with 3, and that's just a negative 3. So we're going to multiply row 1 by negative 3. We're going to add it to row 3 this time, and that's going to replace the row 3. Once again, you go column by column. We start with column 1. I do negative 3 times that 1 equals negative 3. Negative 3 plus that 3 on the bottom row is going to be 0. Then we do this negative 3 times 1 equals negative 3, plus negative 1 is going to be negative 4. Negative 3 times that negative 2 is a positive 6. Positive 6 minus 1 is going to be 5. And finally, we have negative 3 times 5 is negative 15. Negative 15 plus 8 equals a negative 7. Any questions on anything that we just did? I know we have to do kind of a lot in our head. Yeah?
Why is it negative 2 and negative 3? Because they're positive in the thing.
Yeah, exactly. I want to create a 0 pair.
Okay.
So, Liam, kind of think about this. Let me go 2 slides. Let's say we're doing elimination. And that's in fact what we're doing. We're actually just doing elimination. Say I had x plus 3y equals 4. And then I had negative, now let's just make it a positive 2x plus 7y equals 3. And I asked you to use elimination on this. You'd probably multiply this first one by negative 2. So that you'd have a negative 2 over a positive 2x, so it turns to 0. That's exactly what we're doing here. We're creating 0 pairs. So this has to be the other. If this is positive, I need to...
Right, so you're, okay.
Yep, I'm trying to create those 0 pairs. I'm done with that column. Left to right, now we'll work on the next column. And we start with the same thing. We always start with what needs to be 1 in that column. Who can tell me what value in my second column needs to be 1? Yeah?
The negative 3.
The negative 3 needs to be a 1. What can I multiply negative 3 by to make it a positive 1? Not a trick question. What do I multiply negative 3 by to make it a positive 1? Yeah? Negative 1/3. Yeah. So that's in fact what we're going to do. We're going to say, well, I need to make this 1. I need to make this negative 3 a 1. And so I'm going to multiply the entire row by negative 1/3. Neither of the other 2 rows are going to change. We're just doing 1. So my row 1 is going to stay the same. It's going to stay that 1, 1, negative 2, 5. 0 times a negative 1/3 doesn't matter. It's still 0. Negative 3 times a negative 1/3 becomes a positive 1. That's what we needed. 5 times a negative 1/3 is a negative 5 over 3. And finally, we're going to have negative 9 times a negative 1/3 is going to be a positive 3. I did nothing to that bottom row, so that's going to remain a 0. Negative 4, 5, negative 7. So every time we do the same thing in each column. Find what needs to be 1, make it a 1, everything else has to become a 0. So that means I already found my 1. Negative 4 has to become a 0. And 1 has to become a 0. We have fractions in here. We do have fractions in here. And you can't just clear fractions. You can't just clear fractions because in your mind you might be like, well, if I just multiply this whole row by 3, I would get rid of that fraction. But then you would turn this 1 into a 3 and you'd break everything. All right, so you can't clear fractions. You actually have to work with the fractions given to you. All right, so we have a negative 5/3 of 3. I need to turn this 1 into a 0. So once again, I'm just asking myself, what do I multiply 1 by to create a 0 pair with that 1? And that's just going to be a negative 1. Negative 1 times 1 plus 1 is going to equal 0. So our very first thing is we're going to do a negative 1. Or we're just going to say negative row 2 plus row 1 is going to become my new row 1. So we're multiplying everything in this row by negative 1, adding it to row 1, and replacing row 1 with that information. So we have negative 0 plus 1. It's going to stay a 1. Then we have negative 1 plus the original 1. So we're going to have 0. Then we're going to have a negative 5/3, so that actually becomes a positive 5/3 minus 2. This is the time where you probably want to do a little scratch work. A little scratch work to make sure, because we're dealing with fractions and stuff. You can do it wherever you want. I usually try to put it underneath or above somewhere where I did the math. So I'm just going to put a little section right here where I do that little side work. So what I'm doing is, so negative 5/3 is going to be 5/3. So I'm just going to make it into a box eventually. Minus 2. Well, that's 5. Let's not do it that way. It's going to be 5/3 minus 6/3, which equals a negative 1/3. So wherever you want to do your scratch work, that's fine, but that's going to be a negative 1/3. Finally, we have a negative 3 plus 5 equals 2. I'm leaving row 2 alone because it already has the 1 I needed. Now I need to get rid of that 4. I need to turn that to 0. What am I going to multiply row 2 by to get rid of that negative 4? What am I multiplying row 2 by to get rid of that negative 4? Liam?
4.
Yep, just 4. You got it. I would write this underneath it. I don't have the room, so normally I'd write it right here underneath where I don't have room for that, but you should. I'm going to write it right next to it just because I ran out of room. 4 times row 2 plus row 3 becomes row 3. We're going to start with 0 because we already had a 0. 0 plus 0 equals 0. Then we have 4 times 1 plus a negative 4 is going to give me 0. Then we need to do 4 times a negative 5/3, which would be negative 20/3. And then we'd have to add 5 to that. I end up getting negative 5/3. I just don't have a ton of room to do scratch work, so I'm just going to go right to it. You have more room to do scratch work. Make sure you can do that. And then finally we have 4 times that 3 equals 12. 12 minus 7 is going to equal 5. Column done. Now we move on to the next column. What's the first step when I get to a new column? Marley, what's the first step we do when we get to a new column?
You locate what needs to be a 1.
Exactly. Which one needs to be 1?
The bottom negative 5/3.
Yeah, negative 5/3. Yeah, perfect. So we need to turn that into a 1. Can someone tell me how to turn that into a 1? Caitlin, do you know how to make that into a 1? You'd multiply the whole row by negative 3/5, and that's exactly what you're going to do. You are going to attempt to finish this whole thing. You are going to finish the rest of it. Your first step, turn this into a 1. So in this part, you should have a 1. These 2 rows should stay the same. And then you're going to turn these into zeros down in the next one. So work on it, ask questions. You are finishing this problem. I will post the answer in. I'm going to go ahead and post my answer. On the answer key, I actually have everything posted in case you were kind of lost today and you weren't sure and you couldn't quite follow along. I even put that scratch work down here to get to my negative 5/3. But we should have said these 0 pairs aren't supposed to be tricky. If I need to get rid of negative 1/3, it's telling you you need to multiply by a positive 1/3. If I'm trying to get rid of a negative 5/3, I'm multiplying by a positive 5/3. So let's just go through this 1/3 one together real quick. So I multiplied row 3 by 1/3. So I'm just looking at this. So the whole point of that was because 1/3 times 1 equals a positive 1/3 plus a negative 1/3 gives me my 0. And then we do 1/3 times that negative 3. Well, 1/3 of a negative 3 is negative 1. Add that to 2, and that comes out as 1. And then you do the exact same thing with 5/3 times row 3. Any questions on those steps? Ask now. Like I said, I'll have this whole thing posted in case you made a mistake and you want to go back. All right, so let's talk about some special cases. Let's talk about some special cases, primarily dependent and inconsistent systems. This, while solving Gaussian method, is going to be independent. Anytime we have like x equals 2, y equals 3, z equals some value, it's independent. There's one answer. This is the one answer. This is independent. You need to know that this is independent when solving Gaussian style. So that is independent.
Wait, what does that mean?
You might want to watch the videos.
Oh, okay.
Yeah. It just means there's one solution. That's what independent means. There's just one solution. Dependent means there's an infinite number of solutions. Dependent, once again, is infinite number of solutions. When solving using the Gaussian method, we'll see what appears to show me it is in fact dependent. So the directions might just be solve this using the Gaussian elimination method, or the Gaussian Jordan, the Jordan Gaussian. So you would set this up like normal, because you would not know it's a special case. And we'd set it up as the matrix 2, 1 equals 4. On the bottom we have 4, 2 equals 8, and we're going to solve it just like I normally would. Left to right, which one needs to be 1? That is the 2. The 2 needs to be a 1. We can't just flip rows this time, so we have to do row 1 times 1/2. 1/2 row 1 becomes my new row 1. So we're just multiplying both sides of an equation by 1/2. That's going to give me 1. 1/2 times 1 is 1/2. 4 times 1/2 is 2. I didn't do anything to row 2, so it remains 4, 2, and 8. I have my 1. I have my 1. What do I need to do next? Once I have my 1. Yeah. I need to find the zeros. And that's just that 4, right? I just need to turn 4 into a 0. In order to do that, I need to multiply this 1 by negative 4. Once again, once you figure out what needs to be your 0, you should multiply by its 0 pair. So it's going to be negative 4. Since I'm looking for a 4, we're going to go negative 4 times row 1 plus row 2 is going to become my new row 2. My row 1 is going to stay the same. 1, 1/2, 2. Negative 4 times that 1 is negative 4, plus that positive 4 is going to give me a 0. Then we have negative 4 times 1/2 is negative 2. Negative 2 plus 2 is going to give me 0 again. And then we have negative 4 times 2 is negative 8, plus 8 is going to give me another 0. That should automatically jump out at you as going, something's wrong there. Because your next step would be to turn this 0 into a 1, which would be impossible through multiplication. What this bottom row is actually saying, what that bottom row is actually saying, maybe I'll do it in red. What this is saying is 0 equals 0. The variables dropped out. I have 0 x's, 0 y's. I have 0 equals 0. That is true. which means it is dependent. It is infinite solutions.
So if you can't like solve it and it ends up being like that.
If you see a bunch of zeros, it'll always be, you'll see a whole bunch of weird zeros there and you can't do anything with it. If you ever see an entire row of zeros, it is automatically dependent. It is 0 equals 0. So a bunch of zeros showing up, Charlie, should tell you it's going to either be dependent, and we'll see the examples where it's inconsistent as well. You'll see a bunch of zeros in the wrong place. But yes, if you get to the point where you're like, I can't go any further for some reason, it must be one of those two. Liam, did you have a question or you just?
Yeah, never mind.
You sure?
Yeah. Well, what could you do? Yeah, actually, never mind. It won't work.
You actually couldn't go any further.
Yeah, because I was going to say, what if you did 4 times row 1 plus row 2, but that wouldn't work.
Because then you'd go back to creating, yeah, there's no way to maintain that 0 and turn this into a 1. It was good thinking though, because you basically just went in reverse, but like you said, you just keep going back and forth and you couldn't actually solve it. So it's true, it's dependent, 0 equals 0. Another case of this that might show up is our next one. And our next one, you might have to write more notes than I write down here. How many variables do we have? Think about that. How many variables are there? There's 3 variables. How many equations do you need to solve for 3 variables? It is 3 equations. You need 2 equations to solve 2 variables. You need 3 equations to solve 3 variables. You need 4 equations to solve 4 variables, 5 equations for 5 variables, so on and so forth. So, like I said, you might want to take some notes on this one more than I'm writing down. What I'm saying in my head is, yeah, for the matrix, they give me 1, -1, 1, and 2. They give me a -2, a 1, a 2, and a 5. But based upon my notes and looking back at this, I'm going to know that 3 variables need 3 equations. So I'm going to make my third equation. My third equation would have 0 x's, 0 y's, 0 z's, and it would have equaling 0.
So how can you even do that if the bottom right 0 is always that? Yeah, how can you do that?
Because you have to, because they didn't give you the third equation. This whole thing is dependent on your third equation. They didn't give it to you. Basically, your third equation can be assumed to be 0 equals 0. All right, so this is one way to solve this one, to say my third one has to be 0 equals 0. I made that third equation. Because they didn't give it to me, I'm going to make it 0 equals 0, which would make it dependent. If you didn't realize that, like I said, it should be in your notes. This should be the easiest problem on the test if I put this on there. Automatically dependent because I didn't give you the third equation. It is basically what I'm saying is it's dependent on that third one. I don't have the third one, so it's dependent on the fact that 0 equals 0. Another method to do this, I would do it this way. So like I said, I would write notes down saying 3 variables equals 3 equations. That's why we can do this. Or you may have set up your equation like this. You may have set your equation up as 1, -1, 1, 2, and -2, 1, 2, and 5. This is going to be those people that didn't take notes on this, that didn't write something down and don't study it. You're going to come up with something that looks like this. I'm not going to show you all the steps. But if you were to solve, so I'll put a little arrow and I'll put a little note saying missing work, because there is work that needs to be done to get this. You would end up with something that looks like this. 1, 0, 0, 1. You can't get rid of that -3 and that -4. And you have 7, -9. You cannot fully make your identity matrix because your identity matrix needs to have a third row of 1s. So at this stage, you wouldn't have enough to solve it. You would not have enough to solve it. You would have something that looks like this in form. You would have x minus 3z equals 7, y minus 4z equals negative 9. There, you couldn't go any further, so it has to be dependent. Because you can't go any further. It is dependent. So much easier. Just write in your notes that 3 variables needs 3 equations. If I only give you 2 equations, it's automatically dependent because you have the 0 equals 0 row. All right. So that is dependent. Let's talk about inconsistent. Inconsistent system. This one's going to be inconsistent. The first thing I need to do to write it in matrix form is I need to rewrite these in a form so I can put it in a matrix. That means my x's need to be lined up, my y's need to be lined up, and what they equal needs to be lined up. So we're going to alter these into x minus y equals 3. And the bottom one I'm going to rewrite as negative 2x plus 2y equals 5. Then I'm going to put it into a matrix and I'm going to solve it using Gaussian elimination. So we are going to have 1, negative 1 equals 3, negative 2, 2 equals 5. With Gaussian elimination, I work from left to right. I start in that left column and I say what needs to be 1. This 1 needs to be a 1. It is done. So we're going to move on to the next step, which is make everything else 0. So I'm going to make that negative 2 into a 0. Which is just multiplying the first row by 2. So 2 times row 1 plus row 2 becomes my new row 2. 2 times 1 is 2, minus 2 is going to be 0. 2 times negative 1 is negative 2, plus 2 is 0. Finally, we have 2 times 3 is 6. 6 plus 5 is 11. I didn't do anything to the first row. And if I tried to go further, I'd be stuck because I need to turn this into a 1. Which looks just like our 0 row, except for this time, I have a row that says this. This row says 0 equals 11. So Liam, if I give you $0, will you give me 11 back? This says 0 equals 11. No, that's a false statement. That is false, so it is inconsistent. So the way you could think about this, if you're just someone that's not going to look back at your notes, like I said, your notes should say something like 3 variables, 3 equations. If you don't have that third equation, put it like this. If something weird happens and you can't solve it using Gaussian elimination, it's probably either going to be independent or, inconsistent or dependent. You're going to have zeros in there. Inconsistent is going to be a little easier to see because it's going to come up with this 0 equals that. Dependent can sometimes be hard because of this 3 variables, not 3 equations thing. All right, any questions for me? So make sure you look for all for those weird cases where there's a bunch of zeros that just can't solve it. Your homework